Okay, so this is our next problem. We are still solving the linear homogeneous second order ODEs. And in this one, we have y double prime plus 2y prime plus 2y equals to 0. And once again, we're given two initial conditions. So once again, first step, characteristic equation. We get lambda squared plus 2 lambda plus 2 equals to 0. If you don't know where this comes from, you can watch the other videos that we're going to put here in the description where we explain where this one's come from. Okay, so we can factor this one out. Well, no, I don't think we can factor this one out because no number gives me times 2 and then add 2 to 2. So then most likely we need to find the quadratic equation. So we're gonna then name this using the quadratic equation. And how do you remember? And we have then that lambda will be equal to negative b, which in this case it's 2 plus or minus square root of b squared, which once again is 2 squared, minus 4 times a, which is 1, times c, which is 2, everything over 2 times a, which is 1. So let's continue simplifying that. We're going to get lambda, it's equal to negative 2 plus or minus, and 2 squared, that is 4, minus 4 times 2 times 1, that's 8, over 2, which once again we get negative 2 plus or minus the square root of 4 minus 8, that's negative 4, over 2. If we continue, this will be equals to negative 2 plus or minus, so square root of negative 4, that's a imaginary number, so will be square root of 4, that will be 2, and because it's negative, will be 2i over 2. So then we divide everything by 2, and we're gonna get from here that lambda, it's equal to negative 2 plus or minus, well, no, if we divide everything by 2, we're gonna get negative 1 plus or minus I, and this is the root for this equation. So because we got complex roots, you can see that this is neither case 1 or case 2, so it has to be a case 3 of complex roots. And when that's the case, we get then that y, it's in the form of e to the real part times x times c1 cosine omega x, which is imaginary inside, plus c2 sine of omega x. And it's like that. So let's just identify them here. So you can see that beta, it's equal to negative 1, and omega, which is the 1 by the I, it's equal to 1, right? There's an omega here, which is a 1. Therefore, my general solution for this problem, y of x, it's equals to e to the negative x times c1 cosine of omega x, which will be 1 times x, plus c2 sine of x. And this is my general solution. So we were given at the beginning as well two initial conditions. So once again, y of 0 equals 0, y prime of 0 equals 1. So if we're given that, that means we need to use them to identify what our constants are. So let's see, we can already do this. So we can apply the first constant already because we know what the first constant is for y equals 0. So if we apply for this one, you can see that we'll get here y of 0 equals 0. So when x is 0, y is 0, so we have then 0 is equals to e to the 0 times 1 cosine of 0 plus c2 sine of 0. So doing this, if we get simplified, you get that 0 it's equal to, well, e to the 0 is just 1. So this one basically will just go to 1. And we're going to be left with c1 times cosine of 0 plus c2 sine of 0. And if you remember from the very first video, we can go and check right here in the description. Cosine is 0, it's 1, but sine of 0, it's 0. So from here, we're just left with then that c1 it will be equal to 0. We're gonna be equals to that. All right, so we can already know part of the solution. So let's find out whatever c2 is. And to do that, we need to take the derivative. So let's find the derivative of this. So we are going to get then y prime of x, it's equal to, first we can distribute. So this e to the x times this, and then this e to the negative x times c2 sine of x. And in both cases, we will need to apply that product rule. And you can see that from 2 terms, we're going to end up with about 4 terms. So let's do that. So we're going to get here. So the first one, the derivative of e to the negative x is just negative e to the negative x times c1 cosine of x. And the derivative of that will be plus. So derivative of cosine will actually be negative sine. So it will be minus c1 times sine of x. That will minus, that's what we make it a negative here, times e to the negative x. All right, that's for the first one. And then for the second one now, for the c2, so that will be negative e to the negative x times c2 sine of x. And then there will be plus, right? There was always a plus here. And the derivative of sine is positive cosine. So it will be c2 cosine of x e to the negative x. And that's what we get here. Just correct here, negative x. Okay, so when that's the case, we can solve, and we know that the initial conditions that we got at the beginning were that y prime of 0 equals to 1. And we can already eliminate some of these terms, right? We know that the c1 is 0, so we can go ahead and cancel that one out and just be left with the remaining 2 terms, which will be 1 is equals to negative e to the 0 c2 times sine of 0 plus c2 cosine of 0 times e to the 0. And once again, we know that sine of 0 is just 0, so all of that goes to 0. Cosine of 0 is 1, e to the 0 is 1, and we're left then with c2 is equals to 1. And then with this, we can write our particular solution, that for this problem, it's the following. It's then e to the negative x times sine of x, right? Because that's a 2, it's a 1. So this is my particular solution for these exact conditions. So this is our third video in this series. Hope their examples have been helpful. We still got one more, possibly many more to come where we're going to be covering other topics, but that's it for this one. Thank you.